Good evening. We're going to try and diagnose and treat a room with a lot of audio, echoey, weird, unpleasant sounds. These sounds make it quite hard for you to understand what someone's saying when they're speaking, as you're probably experiencing right now. But I can solve at least the artificial echo here. So this is down to one normal microphone. Probably sounds okay at the moment with me speaking because this room's had a little bit of easy treatment. I've put some blankets up and around and some soft furnishings, but otherwise this room's pretty bad. There's a smooth surface in the table, the floor isn't carpet, it's lino, so it's quite reflective and smooth. The walls are bare behind me, the shelves haven't got much on, so it's not an ideal situation. I have done some stuff to rectify it, I'll remove that in a minute, we can test it. But first I want to explain to you where you get echo from in a room, if you can see the diagrams. So, sound bounces around in the form of a wave. So this is a waveform. You get a wavelength, which is where it goes up and across and down and in. The distance that it takes for the wave to do a complete cycle is the wavelength. All sorts of different wavelengths. Within a room, you get an echo when your sound comes out of your speaker and travels across and bounces off a wall and then travels back, and then you get a reflection and it bounces back and forward, and that's why you get an echo, because you make the sound and then a short time later, after it's gone across the room and back, the sound is heard again, either in your ear or in the microphone. That's how it works. And there's a formula that you can use to work out wavelengths, and the worst noises you get in a room are where you get harmonics, where the wavelength is about the same size as one of your measurements in the room. So in this case, if in the example it's a 2 meter across room, I did a formula down there that lets you calculate it. Basically it's the frequency that you'll get a bad wavelength at is the speed, which indoors in air is about 343 meters per second, divided by the dimension that you've got in your room. So say the length of your room is 2 meters, well then you'll have a harmonic frequency at about 171 hertz. Now I can't make 171 hertz for you on this laptop I've got because it doesn't work it, but you'll also get frequencies where you fit 2 wavelengths in, so twice 171 hertz, which is 343, which is the number you start with for the speed. And I can play you that as an example of what that sounds like. Not very nice tone, but clearly right in the audio range. That's an easy loud signal for you to hear. It's probably not far off of some people's speaking voice level, things like that. You will get a whole range of different frequencies. You'll get every multiple will easily match, and that's on a 2 meter length. So the half meter across the short distance of the room in the diagram, you may also get a wavelength going this way. Well, that will be exactly that frequency. And you'll also get another wavelength that matches from the speaker across the diagonal, which, if you know Pythagoras, is the r squared thing, which will be slightly more. And so all those add up, and you'll get harmonics between the floors and the ceilings and the walls as things rattle around. The worst ones are the ones between your source, so that's either your speakers if you're listening to something, or your voice where you're sat speaking, and your receiver, so your ears if you're listening, microphone if you're picking things up. So my speaking will be coming out and reflecting off the wall, and you'll get to hear my voice directly and the reflection of my voice off that wall. And because you don't talk with your sound coming perfectly forward, my voice will spread out a bit and it will bounce off of the wall to my left and my right. It'll reflect off the wall behind the camera, and then back behind the room, and then back again. And so every time it does that, it's quieter every time, but it's all there, it blurs. So a rather simple way to test for this sort of stuff is to make a short, sharp sound. So that's one way of doing it. A nice short sound, or clapping is another one that works quite well. and try it in a few different places because you'll hear different harmonics. Now that might not sound too bad right now because I've got some stuff up, just like blankets over solid furniture and things that will be deadening the sound. I'm going to do two things. I'm going to take the blankets away and test again, and I've actually got some proper audio treating foam type stuff that I'll pop in, and then I'll test after that as well. So I've now removed all of the dampening I'd brought into this room. There used to be a couple of blankets up and things like that, just scattered around. There was one behind the camera here to stop the reflections off there. There's a piece of furniture next to me and I just had that covered with a blanket to give a soft surface. So we're back to a fairly bare room. There was a white thing you could see just up here. This was just a bit of oddly shaped polystyrene that I had wedged up here and just inserted, because otherwise there's a smooth shelf above me. There's a nice flat even area so things will reflect and it will come down onto the desk surface. The desk has got a reasonable amount of stuff on it now, so that's not so smooth. Keyboard and the laptop and the microphone, all the stuff and books and things here will help. Instead of getting a straight reflection going up and down, it'll bounce off it, and then because it's an angled surface it will send it off a different way, which will help to diffuse it. But here we'll see if it's any better or worse without the blankets and stuff in. That's the hang in some sticks and now. So we'll see if that's any worse on the audio. And now the next thing I'll do is I'll fit all the proper insulation products to see if I can make it so that there's almost no echo at all in here. And the doctor will have solved the audio problems. So as you can see, I've got the sound foam barrier membrane stuff up, and the stuff up here as well, all suspended and glued into the bottom of this shelf to help dampen the reflections. There's some behind the camera, there's some all around. So whether this makes any perceptible difference to my speaking, I don't know, but we can try the clap test and we'll see if it has any less echo. So and then the tapping of sticks. To me it sounds like it's less ringing where I'm sat, but whether it sounds like it to you, I don't know. Let me know whether you think the doctor has cured the patient.